If you're following me on Instagram or Twitter, you know that I share some behind-the-scenes materials about future projects, for example my home lab server. And I just came up with this idea because I needed a new server in my home lab where I can just run some virtual machines and have a reliable network-attached storage for all of my files, videos and so on. And of course I also want to explain some of the decisions I made and what you should consider if you want to build your own do-it-yourself home lab server with something like Proxmox. If you want to build your own home lab server, there are many different options you can choose from, and it's all based on your personal requirements. So for example, do you just need to have a backup solution or a storage solution for all your files in your network? Then maybe a NAS solution is a good option. Or maybe you need to run many concurrent virtual machines or want to get access to professional server equipment, then build an entire home lab server rack is maybe also a good idea. And in the past, I've already worked with VMware ESXi and Microsoft Hyper-V in professional companies, but I wasn't really afraid of testing and trying out something completely new. And therefore I've asked you guys on Twitter and Discord, what do you guys want to see? What should I install on that? And how you are running your own home lab servers? And yeah, because Proxmox was by far the most requested topic, I just went with that. But first things first, before we start talking about the operating system, let's also talk about hardware and requirements. Because I know that a lot of you guys want to see professional server equipment and a lot of you guys are already running such systems at home. But let me explain why I have decided to not go with a professional server equipment, but instead build my own do-it-yourself home lab server. So let's take a look at this. So my old server I got is a Dell PowerHT 410, and this is based on professional server equipment you usually see in small or medium-sized offices or even small data centers. And those old server models like the Dell PowerEdge series and the HP ProLine series as well are really good servers you can put in a separate room or in your basement where you can build an entire home server rack. And you will find a lot of great deals on eBay where you can get those older server models very cheap and you get a lot of computing power for a very fair amount of money. But in my opinion, those professional servers have two major disadvantages. The first one is they are extremely loud because of the professional fans, and the second one is because they usually come with two power supplies, and especially the older models are not very efficient. The power consumption of these servers is really high. And in fact, the old Dell PowerHT 410 that I got costs me 3 times my own do-it-yourself home server when we talk about pure power consumption. And because I also don't have a separate room, in fact I only have this small room here where I work and where I create my videos, I cannot go with a rack server because those servers are just too loud. So I just wanted to get rid of this old server. I wanted to get something new, something efficient, that is quiet but still powerful and not too expensive. And because I'm not afraid of building my own PC, in fact I've built my very first own PC together with my father when I was 12, this sounded like a fun and exciting project. And I also had some little help because my 3-year-old son, he came to me and wanted to help me building this PC. And yeah, this was a very cool moment. I really enjoyed building this and yeah, it made a lot of fun. And of course you're also very proud if you've completed this and if you've built your own home lab server completely from scratch. But of course you also need to make some decisions. You need to pick your parts that you put in your server very carefully, and let me give you some recommendations what you should consider when building your own do-it-yourself home lab server. So the first question you should ask yourself is, which processor should you get? Should it be an Intel or an AMD CPU, and how many cores and threads should it have? And well, I cannot really tell you because it's really depending on your own personal requirements. So if you just need that server to store some files and data on that, you probably don't need a very expensive and powerful CPU. But in my case, because I wanted to test and try out many concurrent virtual machines, I needed a CPU that can handle all this stuff. And what I can recommend you is a 6-core 12-thread CPU from either AMD or Intel. Because those CPUs don't cost too much, you can get some very great deals on those mid-range CPUs, but they also have enough power, and some of the modern generations are very efficient also in terms of power consumption. And this is an Intel Core i5-10400 processor, so this is a very great mid-range CPU, comes with 6 cores and 12 threads and up to 4.3 GHz clock speed. So this is definitely powerful enough to run many concurrent virtual machines, but it's also a very good deal. It's not too expensive. On the AMD side, we have the AMD Ryzen 5 3600. It's not the latest generation, not on both of these CPUs, but I always tend to buy one generation older because usually there are better deals, but these CPUs are still very modern, very efficient and very good. So when we compare the benchmarks between the Intel and the AMD CPU, you can see that those CPUs are very even, right? They almost cost nearly the same, and you can see the Intel CPU is slightly faster than the AMD, while the AMD is slightly cheaper. So now, when we talk about AMD versus Intel, a lot of people will tell you, well, it probably is just about fanboyism if you are liking AMD or Intel more, but I can tell you, well, the decision between AMD and Intel is not really that easy, especially when we talk about home server builds. So the first argument for an Intel CPU should be that it has an internal graphics chip installed. So if you just want to build a server and you really don't have any graphical accelerated workflows running on there, you usually don't want to add an additional graphics card into your server, but with AMD you need to do that because the AMD CPU doesn't have an internal graphics chip like the Intel one, and you need to buy at least a very cheap graphics card to just make this server working. I can recommend something like this here, the MSI GT710, which is really cheap. It costs around $40–50, and you should consider that because you can save that money when you go with an Intel CPU. Now AMD on the other side has also some advantages. The first advantage would be that it has a very great stock fan. So the stock fan that comes with the AMD Ryzen CPUs, it are just incredibly good, and I really love to do that. You really don't need to upgrade your CPU fan when you go with an AMD CPU, but it also has another advantage that is very specific to the storage systems and servers, and we will come back to this later. So once you've chosen your CPU, you should also pick up an appropriate mainboard that supports your CPU. So you really should take care that it has the correct socket, because especially Intel likes to change their socket with nearly every generation of new CPUs, so you also need to upgrade your mainboard every time you upgrade your CPU. On AMD this is a little bit different because AMD currently only has the AM4 socket, but you need to take care that not every mainboard generation supports every CPU generation and model. So there are different chipsets around, and because I've used the AMD Ryzen 3600, I've decided to go with this mainboard here, the ASRock A520M Pro 4. So this supports AMD AM4 sockets from generation 3000 up to 4000 and also the newest 5000 series of desktop processors. So you should definitely take care if this mainboard supports your AMD CPU. In my case it does. Nothing really special to this mainboard. Let's talk about storage. And when we talk about storage, it can be highly depending on your personal needs, so how much data you need to store on your server and so on. But what I can definitely tell you is when you install an operating system on a server or on any PC, you should get an SSD over a traditional magnetic hard drive, because this is just so much faster and it really isn't that much more expensive, right? So definitely upgrade to an SSD. Better choose an NVMe drive, something like this here. I picked up the Kingston A2000 NVMe PCIe. So this is a really great NVMe drive. It is not really too expensive, but it has some great values here. So it has high speeds, and this is really great. So what I can definitely recommend you, once you install something like Proxmox or any virtualization technology on your server, you should always put all the virtual hard drives on an SSD. Because what I can tell you from my experience is when you run many concurrent virtual machines and you store those virtual hard disks on a magnetic hard drive, those virtual machines will run extremely slow. So usually the CPU and memory is not the bottleneck on virtual machines, it is in fact the hard drive. So always put the virtual hard disk of all your virtual machines on an SSD drive. It will make run your virtual machines so much faster than using a traditional HDD. But now when we talk about data in large storage pools, no, you probably can go with an SSD, but there it can get really expensive, especially when you need large disk sizes. So for a storage pool, I always would go with traditional magnetic hard drives if the speed is not really so critical to you. So in my case, I wanted to build a storage pool with ZFS. I've talked about this in previous tutorials as well, because ZFS is a software RAID that allows you to add some redundancy to your hard drive. So for example, you can spin up like 3 or 4 hard drives and add one hard drive as parity. So you can't use the space of one hard drive, but in case one of your hard drives fails, you always have your data stored on all the other hard drives. You don't lose any data when one drive is damaged. So building something with ZFS or also BetterFS on Linux is a really great idea, and you can definitely do that with traditional magnetic hard drives, because ZFS also can add some caching and put this on an SSD where you can actually speed up your storage pool as well. So we have a lot of options there. But one thing that is really important when we talk about software RAIDs and ZFS storage pools is which memory should you get. So because you will find a lot of articles or people on the internet that will tell you that you should never run a ZFS storage pool without ECC memory. So for people who don't know what ECC memory is, let me explain this quickly to you. So ECC stands for Error Correction Code, and this is a specific function in some memory modules that can detect and repair data corruption that happens or occurs inside the memory. So this is a common technique on any professional workstation or server equipment. You commonly will see that on any professional server hardware, yeah? Always everything runs with ECC memory there. But it is not really common on any desktop or laptop PCs, because you usually don't need that. So the problem is when you want to build your home lab server with desktop technologies, you barely find ECC support there. And this is because usual desktop PCs that use file systems like NTFS or X4 when you want to run Linux, they don't really require ECC memory for their file system integrity. So what can happen is when there is a data corruption happening on your file system and you're running NTFS or X4, this usually isn't a big deal on any desktop PCs, because when there is 1 or 2 bits damaged, you probably are not able to access 1 or 2 files, but the entire file system is still accessible to you, and sometimes Linux and Windows are even able to repair and restore some of these data corruptions that happens on the file system, and you can always repair that somehow. So the problem is really only with software RAIDs like ZFS or BetterFS. And this is because those software RAIDs usually operate a lot in the memory and not just on the hard disks. So because there's a lot of caching and a lot of other operations happening in the memory before the data is written back to the hard drives. So now if a data corruption occurs in the memory and this is immediately written back to the disk without any further repair or correction mechanism, you can get your file system damaged. So as I said, on NTFS and X4 this is not a big deal, you can probably repair it or also access all other files. Now this is very different on ZFS or also BetterFS, because if there is damaged file system, you cannot access the entire file system anymore. So all your files are probably damaged or lost or corrupted, and there are literally no really good tools to repair this. And yeah, this now sounds pretty worrying to you. In fact, it sounded to me as well. But you need to consider, when running a ZFS storage pool, you need to ask yourself, is the data that you store on this storage pool really so important? And do you have a functional backup mechanism that is probably stored somewhere else? So if this is the case, you probably can just go without ECC memory, because it is very unlikely that something is damaged, but if it does, well, you probably can always go back and restore the files from a backup. So in this case, it probably isn't a really big deal. But as always in technology, things can go wrong, things can be damaged, and if there is a data corruption happening in your memory that is written back to the disk and it completely wipes out your entire storage pool and you don't have a functional backup, or you want to build a reliable storage pool, then this probably should worry you. In fact, it worried me as well, so therefore I just went and searched for a solution to run ECC memory on desktop hardware, which is really uncommon. But luckily there is an option, yeah, and thanks to the guys on my Discord server who pointed me in the right direction, because there are 3 different types of memory here. The first one is the unbuffered non-ECC memory. This is the usual consumer memory you will find on all desktop PCs, on all laptops. Then we have the buffered ECC memory you usually find in traditional server equipments, rack servers, workstations and so on. But we also have the unbuffered ECC memory, which is an ECC memory that is supported on some CPUs and some mainboard models. So now we need to step back to our original decision between AMD and Intel CPUs, because ECC mode or unbuffered ECC memory is usually not supported on most Intel CPUs that are consumer-like. So for example, the Intel i5 series usually doesn't support ECC. In fact, just a few CPUs of Intel that work on desktop hardware, like some of the Xeon models, supports ECC mode. So on AMD this is completely different. So almost every AMD Ryzen supports ECC mode, and also most of the mainboards you will find there also have a supported option for that. You need to take care and look carefully at the specifications, because sometimes it's not really easy to identify whether your mainboard is supporting ECC mode or not. And this is actually the reason why I've chosen to go with the AMD Ryzen CPU and this particular mainboard here, because it supports ECC mode. If you go to the specification, you can see that when you go to the memory, you will see all these memory types are supported, and also ECC and non-ECC unbuffered memory is supported, which is the evidence of this should run. But it is not really easy to find ECC memory that is supported on consumer hardware, and it really took me quite a long time to find something that comes with high clock speeds, but is also supported on consumer hardware for a fair price. So therefore Kingston is always a great resource to find memory modules that are good and supported on various types of hardware, and I can strongly recommend this model to you, so the KTH PL432E. So this particular model comes in 4 different ways. So the first one is 8 GB, 16 GB and also the 32 GB. You will probably find that on Amazon or on some vendors. I will later show you where to find all the different parts of my home server build, so don't worry about that. And how much memory you need is completely depending on your virtual machines. If you just need that for storage pool, you can probably go with 5 GB of memory. Linux will run fine with that, but as long as you want to deploy many virtual machines, you probably want to upgrade to something like 32 GB like I did, or maybe even more. So that's really depending on how many virtual machines you're running and how much memory you will need on all these virtual machines. And hopefully you will find a case where there is enough space for all the parts you want to put into your home lab server. And I've decided to go with something new, a vendor that I've never chosen before, but the cases from Nenoxia, especially the Deep Silence series, sounded pretty promising to me, because they have enough space for all the hard drives to build a really large ZFS storage pool with traditional magnetic hard drives. So when you go to the Deep Silence series, you can see this is a very simple and a very clean design. I really like it, and you can also find this case in many different sizes, which is pretty great. So depending on which mainboard you got, if you got an ITX or maybe a full-size ATX mainboard, you definitely can find a case where your mainboard fits in and where there's enough space for all your hard drives you want to put into this server. And it also is not too expensive, so that's really great. And I really like the cage to mount all the hard drives. You barely find that on modern PC cases, and therefore I just went with that. As a power supply, I usually just choose something from Be Quiet, because this is a German manufacturer, and yeah, I just like German products. They are really great, of course. And I think I just went with the System Power 8 series, which probably is the previous series of this one here. And this is nothing really special, but it definitely has enough power, and it also supports the gold standard, so this should be a very efficient and a very good quality power supply here. And if you're now wondering, well, where can I get all the parts, where I can get the links, and if you want to buy the same parts like I did, or you want to get some other recommendations for other builds or future updates, well, I want to show you my new kit page. So on kit.co, the digital life, you can find all my different builds. I will regularly update when I want to share some hardware recommendations with you if I build something new. For example, if you're wondering which camera, microphone and everything else I'm using in my YouTube studio, then you can just click on that and you will find a link to all the different equipment parts and everything. And of course also this home lab server build I've just did. So when you click on that, you will find all the different parts like the Nenoxia Deep Silence case, the mainboard, the Ryzen processor, the Kingston 1, DDR4 memory module, the NVMe drive, and everything I've built with. And of course, you will also find links to Amazon and maybe some other vendors where you can just get the parts. And of course, if you're using the Amazon links, you're also supporting my channel. So I hope this is a comfortable way for you to find all the different parts and links, and where I can also share in the future recommendations. So you can just go to my personal page there, just follow me there, and you will get all the updates when I release a new home lab server build or any other recommendations. And yeah, then I ordered all the parts. They arrived pretty quickly and I immediately started building this together with my son, so that was really cool. I really enjoyed building this stuff. And I also want to show you something about Proxmox and how I installed that and what you can do with that. So yeah, let's take a look how I installed the operating system. So when you want to install Proxmox on your home lab server, it's really not that difficult. You just go to the official homepage proxmox.com, go to virtualization, and then you will find the Proxmox virtual environment, also sometimes called Proxmox VE. And this is an operating system that is based on the Debian Linux distribution and adds some management software on top of that. And it's also based on Linux KVM hypervisor and Linux containers with LXC. So with that software, you have an integrated web interface where you can manage all your virtual machines. You can also manage networks, containers, high availability clusters as well. So this is really cool. So to install that, you just click on downloads and download the Proxmox virtual environment, download the ISO image, and use a tool like Rufus to build a USB stick. So one thing that you should consider is, because I ran into this error you sometimes see when you want to install Proxmox, you need to go to the Rufus tool and then select the DD option to write the ISO file to the USB drive, and then you are able to install Proxmox. So it was just a small issue that could be easily fixed, so there was really no problem with doing this. And once you have installed that, you can manage your virtual server over this web interface here, where you can also add other servers. You can build some clusters with that as well, so this is really nice, and you can manage your Linux machine with that. So you can open a remote shell, which is pretty cool. You can also see the network devices, add other virtual network switches for your virtual machines. You can manage DNS settings, host settings, time settings. You also have a firewall, which is also pretty nice. Of course, you can also manage storage pools in LVM or also ZFS storage pools, which we have talked about in the hardware section. So if you want to create a storage pool directly on Proxmox, you can definitely do that. So just click on ZFS and then you can select your magnetic hard drives, for example, to build an entire storage pool with RAID Z. For example, let's pick RAID Z1, which should be equal to a RAID 5, so this is also pretty great. And you could also add compression to that, and this will actually gain you some performance upgrades to traditional file systems. And I also managed to add some virtual machines. So for example, I have a small Ubuntu server that is currently running, where I usually deploy some of my Docker containers and Portainer and all the other stuff that I usually teach you in all other videos on this channel here. But I also think of creating a TrueNAS machine, a virtualized TrueNAS, and pass through all the hard drives to that TrueNAS virtual machine, so I can manage a ZFS storage pool and all network drives and something like a NAS solution virtually on my home lab server as well. So this is really nice. I will start working on this project in the coming weeks, and yeah, I hope this will work. So yeah, this is the current state of my home lab server project. As you can see, I've not done so much with that, but it's just a starting point. I just wanted to talk about this server, about the different hardware requirements in the operating system and so on. But now it's up to you. So what do you want to see here? Do you want a dedicated tutorial on Proxmox? Do you want to see something with virtualized TrueNAS and ZFS storage pools? Just let me know in the comments. So I hope you enjoyed this video and you could learn something, and you now feel a little bit more comfortable with working on your own home lab server project, and you're not afraid of building your own do-it-yourself home lab server, and you know what you should consider when doing this. So if you enjoyed it and this was helpful to you guys, then please don't forget to hit the like button and of course subscribe if you want to watch more tutorials and content for IT professionals. And as always, take care of yourself, and I hope I see you soon. Bye bye.